Hi, this is Jelyn from the Honors Tutorial. Welcome back to part 2 of our topic, which is about Greatest Common Factor, or GCF. This is for Mathematics 4. Let's have this example. Let's do this by the use of listing method 35 and 40. Solution. Letter A, we have here 35. So think of two numbers that when you multiply is equal to 35, and that is 1 times 35. How about 2? Is it possible? No, it's not. Is 3 possible? No. Is 4 possible? No, it's not. 5. Okay, so we have here 5 times 7. 6 not possible. 7. If you're going to write 7 times 5, please don't write it because because you already have 5 times 7 here. We have here same numbers. So therefore we will be removing 7 times 5 here. And that's it. There's no other factors other than 1 times 35 and 5 times 7. So therefore we will be writing it in increasing order now. So that is 1, 5, 7, and 35. Next, letter B. Letter B, we have here 40. For 40, think of two numbers that when you multiply is equal to 40. That is 1 times 40. 2 is possible. 2 times 20. 3 is not possible. 4 is possible. 4 times 10. 5 is also possible. 5 times 8. 9, no. 6, no. 7, no. 8. If you're going to write 8 times 5, please don't. Because you already have 5 times 8, it will become redundant for the numbers to be there. So just remove it because it is still 5 and 8 in different position. 9, no. 10 also. If you're planning to write 10 times 4, please don't write it. It is because you get the same number, 4 and 10 still. So that's it. Let's write it in increasing order. So we have here 1, 2, 4, 5, 8, 10, 20, 40. So now let's look for the GCF of these two numbers. Let's write the factors here. So we have here 35 equals 1, 5, 7, 35. For 40, we have here 1, 2, 4, 5, 8, 10, 20, 40. So these are the factors. Kindly choose the greatest factor that 35 and 40 have in common. So 1 is a no, 5. Let's check 7, no, 35. So therefore, we have here our GCF, and that is 5. Because though we have here 7 and 35, but it is not in 40. So therefore, for the GCF, we have here 5. And that's it for the listing method. Now let's have the ladder method. This is more easier than the first method that we have. But you should know the prime numbers. Okay? So let's have this solution. We will solve this separately. So we have here 12. And then kindly think of a prime number that can divide 12, and that is 2. If you want to use 3, it's fine. 12 divided by 2, that's 6. Think of a prime number that can divide 6, we can use 2. 6 divided by 2 is 3. Prime number that can divide 3 is 3. 3 divided by 3 is 1. So for 12, we have here 2 times 2 times 3. Now let's solve for 60. So think of a prime number that can divide 60. That's 2. 60 divided by 2, that's 30. Think of a prime number that can divide 30. We can use 5. 30 divided by 5, that's 6. Prime number that can divide 6, that's 2. 6 divided by 2, that's 3. Prime number that can divide 3, that's 3. So 3 divided by 3 is 1. So for this, we have here 2 times 5 times 2 times 3. Now let's find the GCF. I will write it here. So for 12, we have here 2 times 2 times 3. For 60, we have here 2 times 5 times 2 times 3. So for the GCF, we should look for partners. Okay? So for example, 2, it is in 12 and it is in 6 also. So therefore, they are partners. 2, there is a partner again for 2, this one. And for 3. But for 5, there's no partner for 5, so it is not included. So for the GCF, you have here 2 in one box. So therefore, you will just write it once. So you have 2 times another 2 in a box. So 2 times 3 in a box. So that's 3. Write the number once only. We don't want redundancy sa loob ng box. Okay? So here in our box. So 2 times 2, that's 4 times 3. 4 times 3 is 12. So therefore, the GCF here is 12. Okay. So that's it for the part 2 of our discussion. Kindly watch the last part of this discussion, that is for part 3. Okay, if you have questions or clarifications regarding the topic, kindly message us, the Honors Tutorials page. Thank you and God bless.